Okay, well, welcome back. We're going to continue now with some more examples. So last video we looked at these two problems on the left-hand side here. Now we're going to do a couple more multiplication examples. And so our first example here is y plus 5 squared. Be careful here. Be careful here. That is not y squared plus 25. Okay, that is not y squared plus 25. Right? And you might think, well, why not? Why not? I'm squaring it, so why can't I just square the y? Why can't I just square the 25? Well, I'm not able to do that because exponents don't distribute over addition. So, numerical example here, 1 plus 1 quantity squared. On the one hand, 1 plus 1 is 2, 2 squared is 4. If you tried to distribute the exponent through, you'd have 1 squared plus 1 squared, which would be 1 plus 1, which would be 2. So exponents, unfortunately, do not distribute across addition. If we can't do it in a numerical problem like 1 plus 1 squared, then we certainly can't do it when we introduce variables. So just be aware that you can't do it. It's really tempting to do it. It's a common mistake that people make very often, but we can't do it. So how are we going to do the problem then if we can't take the exponent and distribute it through? Well, we remember what an exponent means. An exponent means to multiply something times itself that many times. And since it's squared, we would be doing y plus 5 times itself. And then we just use our multiplication idea. So again, distribute. Y times the y times each thing, y times the y and the plus 5, and the 5 times the y and the plus 5. And then we start to multiply out. Y times y would be y squared, y times 5 would be a 5y, and then 5 times y will be another 5y, and then 5 times 5 would be 25. And then just like in the example on the left-hand side there, we do have some like terms. 5y and a 5y would make that 10y, so our final answer is y squared plus 10y plus 25. So really important, exponents do not distribute over addition or subtraction. Okay, you can distribute them across multiplication. That was one of our rules for exponents. But we can't distribute it across addition or subtraction. Okay. Let's look at another example here of multiplying two binomials. This one's something strange is going to happen as we work the problem out. Starting it off, nothing different, right? 2a is going to distribute to both of them, and the minus 9 is going to distribute to both. So we do 2a times 2a. 2 times 2 is 4. A times a is a squared. Then we're going to do 2a times positive 9. 2 times 9 is 18, so that'll be 18a. Then we move on to the minus 9, taking it times each thing. Minus 9 times 2a is minus 18a. Minus 18a. And then minus 9 times minus 9 is going to be negative 81. And then something kind of interesting happens here. The 18a, one of them's positive, and the other one's negative. So they just wipe each other out. So the a's just completely disappear from the problem in this case, and we get an answer of 4a squared minus 81. So this is kind of an interesting one because it did not have an a term or an x term if we had been using x as our variable. Right? It did not have one of those. And so it just ends up having a squared term and a number term. This is something later on we're going to come back and look at this situation again in the next chapter when we get into what's called factoring, which is actually going to be taking a multiplication or an answer like this and going backwards into a multiplication problem. But for now, just be aware that there are ones like that where you may not have an a term. Something may just completely cancel out.